Assalamu alaikum students. Today we will solve the questions regarding independent events and dependent events. First of all, independent events. Two events are independent events if the chance of one of them occurring does not affect the chance of other event occurring. Uh, For example, if we have two bags and there are three cards numbering 1, 3, 5 in the first one and 2, 4, and 6 in the second bag. Then if I draw the cards from first bag and the second one bag, the probability of getting a particular card from the first and the probability of the getting a particular card on second, they are not dependent on each other. So that is why independent events, they do not affect each other probabilities. So if A and B are independent events, then probability of A and B or probability of A intersection B will be the product of the individual probabilities, like probability of A and multiply by probability of B. Whereas example is just like there are 25 boys and 15 girls in a class. 12 of the boys and 5 of the girls wear spectacles. A class monitor and a class monitress are selected random from the 25 boys and 15 girls respectively. Monitor from the boys and monitress from the girls. So what is the probability that both a class monitor and monitress wear spectacles? So as boys and girls are independent of each other, so their probabilities will be independent. Like the probability of a monitor wearing a glass will be 12 because there are 12 boys in the class who wear spectacles and divided by total number of boys. So this will be 12 over 25. Similarly, probability of the monitors wearing spectacles will be number of girls who wear spectacles 5 divided by the total number of girls, which is 15. So the probability will be 5 over 15 or 1 over 3. So their individual probabilities will be multiplied each other to get the probability of a monitor and monitors who wear glasses or spectacles. So 12 over 25 multiplied by 1 over 3, so it gives you 4 over 25. So this is the case when the events are independent. All right, next topic is dependent events. So I make this concept understand for by giving you some example. That's example number 10. Out of 33 students in a class, 21 study geography and 12 study history. No student studies both subjects. Two students are picked at random from the class, from the whole class. Find the probability that the first student studies history and the second studies geography. So we're going to make a tree diagram for it, like you can see in the solution for the tree diagram for both subjects, geography and history. Similarly, if for the first row and if the second student is chosen, then another branch will be formed of this tree diagram. You can see that the second branch G and H, and if the first one is the student who studies history, and then the second student might have might study geography or history. So there are two branches for this tree diagram. So there are 21 students study geography. So it means the probability will be 21 over 33. And you can see that one student has been chosen geography student. So the number of geography students will be 21 minus 1 or 20. So that is what the new probability will be 20 over 32. Now you can see that these two probabilities are dependent on each other. The first probability was 21 over 33, and because we have chosen a first student who studies geography, that is why the number of students who study geography are 20 now, not 21. So that is why the probability will be 20 over 22. 32. It means the probability of the second row will be dependent on the first one. So that is why these are dependent events. So we will apply these concepts on exercise 3C. So this is exercise 3C or D-4 book. So question number 1. Ethan has two bags, each containing five black marbles and red. So it means five black and black, 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 and four red, 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 and red. So this is actually the sample space. So he takes one marble at random from each bag. So this is actually the first bag, whereas the second bag will be black, 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 red, red, red. So this is actually the second bag. The first bag, and this is second bag. So copy and complete the tree diagram shown below. In the first bag, the probability of getting the black will be 1, 2, 3, 4, 5. You can see the number of marbles are 5 black marbles. Divide by total 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is 5 over 9. Whereas if he gets red back, the probability will be 1, 2, 3, 4, 4. There are four red marbles, and total number of marbles are 9. Similarly, for the second bag, as these are independent events, because bag 1 does not depend on bag 2, or bag 2 does not depend on bag 1. So if I choose a black marble from this, the probability will be 1, 2, 3, 4. The probability of getting black marble will be 5 over 9. Similarly, for red, 4 over 9. In this branch, if we get red from the first bag, the probability of getting black marble from the second bag will be the same, 5 over 9. And for the red, because there are 4 red marbles, so 4 over total number of marbles are 9 in the second bag. This will be 4 over 9. So part B, find the probability that the Ethan draws a black marble from the first bag. So obviously it is a black marble. There are 5 black marbles in the first bag divided by total 5 over 9. Part 2, a red marble from the second bag, given that he draws a black marble from the first. So the branch will be black, this will getting black marble from the first and second from red from the second. So this is the branch. So their probabilities will be multiplied each other, or the product will give you the product of their probability give the probability of the second part. So second part will be product of the 5 over 9 multiplied by 4 over 9. So it gives you 20 over 81. Third part, a black marble from the first bag, A black marble from the first bag and a red marble from the second bag. Black and red. As for the second part, a red marble from the a red marble from the second bag. Given that it means they are independent events, so whatever we get from the first bag doesn't depend on the second, or it doesn't affect on the second one. So we don't need to multiply it this 5/9 part with it. So this is a correction. So this will be 4/9 to the red. The third part, a black marble from the first, this one black, and red marble from the second. So their probability will be multiplied each other. So 5/9 multiplied by 4/9. So it gives you 20/81. Fourth part, a red marble from the second bag. So again, whatever we get from the first bag, it doesn't affect the probability of the second of red marble from the second bag. So its probability will be number of reds 4 divided by total number of marbles in the second bag 9. So this will be 4/9. Okay, next question. Question number 3. Question number 3. Statement is the diagram below shows two disks, each with 4 equal sectors. Each disk has a pointer which, when spun, is equally likely to come to rest in any of the 4 equal sectors. All right. In a game, the player spins each pointer once. His score is the sum of the numbers shown by the pointer. So each sector has equal chances. So both are fair disks. First disk number written 10, 20, 20, and 30. Second disk number written 0, 30, 30. These are the scores. In part A, we have to complete this tree diagram. In the first disk, the probability of getting 10 will be, obviously, there is only one sector for 10. 1 over total number of sectors are 4, so 1/4. Whereas 20, two sectors of 20, the probability will be 2 over total number of sectors 4, 4. For getting 30, the probability will be only one sector of 30, so 1 over total number of sectors 4. Similarly, for the second disk, getting 0, the probability will be 1/4 because number of sector, there is only one sector which has 0 on it, divided by total number of sectors 4. For getting 30, there are 3 sectors 1, 2, 3. This one is 1, 2, and 3. So there are 3 sectors. So the probability will be 3 over total number of sectors 1, 2, 3, 4, 4. Similarly, we will repeat these two probabilities here as well. 1/4, 3/4, because they are independent on each other. First test and second test, the chances are, or getting any score is independent on the first disk. 1/4, similarly 3/4. So we have filled this tree diagram. Sum 10 plus 0, 10. So 10 plus 10 plus 30, it gives you 40. Similarly, 20 plus 0, 20. For this branch, 20 plus 30, 50. Or written 30 plus 0, 30. And 30 plus 30, it gives you 60. Part B. With the help of the diagram, calculate the probability that the first number obtained is less than or equal to the second number obtained. First number is less than or equal to the second number obtained. So you can see that in this, the first 10 is greater than 0. The first should be less or equal 10, 30. This branch. This branch. Similarly, 20 greater than this one. 20 is less than 30. So this branch fulfills the condition. 30 greater than 0, 30 equal branch. So there are three branches which fulfills this condition. So we will add their probabilities. First of all, we get the individual probability of each branch. So it will be 1 over 4 multiplied by 3 over 4 for this. So part B first. The probability of first branch will be 1 over 4 multiplied by 3 over 4. This is for first. Then for the second one, 2 over 4 multiplied by 3 over 4. So actually we are taking product of individual probabilities of each branch plus and then adding them. 1 over 4 multiplied by 3 by 4. Simplifying it, this will be 3 over 16 plus 2 into 3, 6 over 16. 1 into 3, 3 over 16. Finally, we get 3 plus 6, 9 plus 3, 12. 12 over 16. Or we get 3 over 4. Second part. The second number obtained is 0. Second number obtained is 0. This branch or this one and this. Okay, repeat the same process. Second part. 1 over 4 multiply by, this is 1 over 4 again, 1 over 4. Then this one is 2 over 4 multiply by 1 over 4. Plus, then 1 over 4 multiply by 1 over 4. So we get 1 over 16 plus 2 over 16 plus 1 over 16, or equal to 4 over 16 or equal to 1 by 4. Next part C. If the player score is between 10 and 50, but excluding 10 and 50, he receives $2. If his score is more than 40, he receives $5. All right. Otherwise, he receives nothing. So, what is the probability that he receives $2? Excluding 10 and 50, between 10 and 50. So, this is actually just sum gives you a score. So, 10 is not included. So, that is why I didn't choose this, the first branch. Second one, 40, yes. Then 20, 50, 50 should be excluded, so 30. So there are three branches in which the scores is between 10 and 50. So the probability will be part C first, this branch, this one, and this one. So the probability will be 1 over 4. Just multiply the individual probabilities of first is and second is. 1 over 4 multiply 3 over 4 plus, and then add them. 2 over 4 multiply 1 over 4 plus 1 over 4 multiply 1 over 4. So 3 by 16 plus 2 into 1, 2 over 16 and 1 over 16. So we get 6 over 16 or 3 by 8. Next part 2. We're getting $5. $5. If his score is more than 40, he receives $5. So more than 40 scores will be this one, 50 and 60. So there are two branches. This first one and this is the second one. So will be for the first branch, which is 2 over 4 multiplied by 3 over 4. Plus for the second one, 1 over 4 multiplied by 3 over 4. So we get 6 over 16 plus 3 over 16 or equal to 9 by 16. For part 3, $2 or $5. It means their probabilities will be added. Probability of $2 plus probability of $5. So probability of $2 was, we get in the part 1 was 3 over 8, and probability of, which is actually third part, and probability of getting $5 was in the part 2, we have found that 9 over 16. So it gives you 16, 6 plus 9 or equal to 15 over 16. Fourth part. Getting nothing. So just subtract the previous probabilities from 1, because total probability is 1. So subtract it 15 over 16 from 1 to get the probability of getting nothing. So it will be 1 over 16. Next question, question number 5. In a group of 8 boys, 3 are left-handed. The remaining 5 boys are right-handed. If a boy is chosen random from the left from the group, state the probability that the boy chosen is left-handed. A second boy is then chosen at random from the remaining 7 boys. What is the probability that the second boy is chosen is also left-handed? So, so the answer of this will be this. If a boy is chosen at random from the group, state the probability that the boy chosen is left-handed. So left-handed boys were 3 over total number of boys 8. So its answer will be 3 by 8. In part A, the second boy is then chosen random from the remaining 7 boys. What is the probability that the second boy chosen is also left-handed, given that the first boy chosen is left-handed? So these are dependent events. So if I write here, there are 3 left-handed left, 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 and 5 right-handed right, right, right. So given that the first boy chosen left-handed, so it means we have to remove this left-handed boy first. Then we have to choose the second boy from these number of boys. The boys left. 2 left and 5 right-handed left. So the probability of getting the second boy as a left-handed boy, it will be 2 over 1, 2, 3, 4, 5, 6, 7, 2 over 7. Because one left hand already chosen. Another equation, 2 boys are chosen at random from the same group of 8 boys. Copy and complete the tree diagram shown below. So the first row or first boy, the probability of getting left hand will be 3 over 8. As there are 3, there you can see that left, 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 right, right, right. So this is actually the sample space. So there are 3 left-handed for the first boy, and for the first row, for getting right-handed, it will be 1, 2, 3, 4, 5. 5 over total number of boys are 8. So for the first, for this left-handed chosen, already chosen. So I'm removing this left-handed. Now we have this sample space, 2 left and 5 rights. So getting a left hand will be 1, 2, 2 by total number of boys 7. Similarly, for getting right handed 1, 2, 3, 4, 5, and total number of boys 1, 2, 3, 4, 5, 7, 6, 7. You can see that. So if the first boy chosen was right handed, I'm writing the initial sample space, left, 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 and 5 righties. So if the right has chosen already, then this I'm removing this right. Now the sample space will be 3 lefts and 4 rights. So the probability of getting left if the right has chosen will be 1, 2, 3, 3 over 7. And for getting right will be 1, 2, 3, 4, 4 over 7. So this is the complete tree diagram for this particular experiment. Part C, find the tree diagram in B, find the, from the tree diagram in part B, find the probability that the first boy chosen is right-handed, first one is right-handed, and the second boy is left-handed. So right, left, this branch is this. Part C, so it will be 5 over 8 multiplied by 3 over 7. So it will give you 15 over 56. Part 2. Both boys chosen are left-handed. Left, left. This one. So probability will be 3 over 8 and 2 by 7 the branch. 6 over 56 or 3 over 28. Third part. The second boy chosen is left-handed. Second boy chosen is left-handed, so there are two branches. Like this one, the first one is left-left. The second boy chosen is left-handed, and this one as well, right-left. So we will add individual probabilities of each branch. 3 over 8 multiplied by 2 by 7 for the first branch, plus for the second one 5 by 8 multiplied by 3 by 7. So it will be 6 over 56 plus 15 over 56 or 21 over 56. Or 7 21 and 7 8 56. So final answer will be 3 over 8. Question number 7. A bag contains 6 green and 4 blue cards. A card is drawn and then find the probability that it is green. So it is very easy. There are 6 green cards, so 6 divided by total number of cards 10. So it will be 3 by 5. Next part. The card drawn is returned to the bag, and after mixing the card thoroughly, Shirley takes 2 cards at random from the bag, one after another. Using the tree diagram, calculate the probability that the Shirley has taken out 2 green cards. So we have to make the tree diagram first. So there are 2 draws: green, G for green, and blue for B for blue. For the second draw, G and B, and if she gets blue in the first, then there are 2 more branches for green and blue. So the probability of getting green the first draw, this is actually draw number 1, draw 1, and this one is draw 2. So the first draw, the probability of getting green will be number of green 6 over total number of cards, and for getting blue 4 over 10. And with the second row, as you can see that G is replaced, or he put green. If he gets if she gets green in the first row, she replaces green again. So it means the probability of getting green will be 6 over 10 instead of 5 over 9. Similarly for blue, 4 over 10. And if she gets blue in the first row, the chances of or probability of getting green in the second row will be same, 6 over 10 and 4 over 10 for the blue. So this is the complete tree diagram for this particular experiment. Part 1, 2 green cards. So this is the branch, green, 6 over 10 multiplied by 6 over 10. So it gives you 36 over 100 or 9 over 25. So I'm making some correction in the tree diagram. It's actually said Shirley takes 2 cards at random from the bag, one and after. It means she doesn't replace it. Well, she didn't replace this. So it means the probability will be, because there are 4 greens I'm writing here, green. These are 6 green cards and 4 blues. Blue. So if G has been taken, so it means There are 5 G's left, and total number of cards will be 9. So the probability of getting another G will be 5 over 9, and for getting B or blue card, it will be 4 over 9. Similarly, this was actually complete sample space. If B has already been chosen, so it will be the total number of cards will be 9 now, and three cards are blue and 6 cards are green. So the probability of getting green will be 6 over 9, and getting blue will be 3 over 9 now. So this is actually the tree diagram. So in part 1, the two green cards. So this is actually green green. So 6 over 10 multiply by 5 over 9 equal to 30 over 90 equal to 1 by 3. Part 2, one card of each color. One card of each color. So it will be green blue or blue green. So there are two branches. So 6 over 10 in the first branch multiply by 4 over 9. In the second one, 4 over 10 multiply by 6 over 9. So we get 24 over 90 plus 24 over 90 equal to 48 over 90, or 6 8s are 48 and 6 15s are 90. 8 over 15. Part 3. At least one blue card. At least the first, second branch, and third one. You can also find this probability by subtracting the branch left, which is green green branch. So 1 minus the probability of getting green 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 green. 1 minus 1 over 3. We got green green probability in part 1. So it will be total 2 by 3. Or you can also add their individual probabilities to get this 2 by 3. This is your home assignment. Question number 1, 2, 3, 4, 5, 6, and 7 of exercise 3C. Okay, take care. Allah Hafiz.